Let's look at the next one. The next one is also a line. Again, if you're not sure how to graph it, feel free to put it in slope-intercept form. So starting out, to put this thing in slope-intercept form, we would start by subtracting the x from both sides, which would give us 2y is less than negative x minus 2. Lastly, what we would do is that we would divide everything on both sides by a positive 2, which would give us y is less than negative 1/2 x minus 1. So that means in order to graph this, we'd start out with the y-intercept, which is negative 1 here. So that's down on the y-axis at negative 1. And then we'd use our slope, which is negative 1/2, as our rise over run to get a second point. Well, if it's negative 1/2, that means we'd actually go down 1 and over 2. So down 1 and over 2 from our pink y-intercept point will put us over here. Once you have both points, you can draw your line, but be careful. Remember that there is no equal to. It's a strictly less than, which means it's going to be a dotted line again. Then the last question really is, which side of the line do you need to shade? Well, to figure that out, let's test a point. Let's test. Again, we're lucky we can test 0, 0 over here because it is not on the line. So test 0, 0 by plugging in 0 for x and 0 for y. What happens if you do that is then we get 0 plus 2 times 0, which is 0. So this whole left-hand side becomes 0. And on the other side, we have less than negative 2. Is 0 less than negative 2? Absolutely not. So the point 0, 0 does not work, which means we have to shade the other side of the graph. So we're going to be shading the lower side of the graph. And we are done. That's it. Notice for the next graph, we have a much simpler graph because there is only an x in the equation. If there's only just an x or only just a y, remember we have a special type of equation. In this case, only an x means we have a vertical line. So we have a vertical line at x equals 2. Notice, because of the equal to, it's going to be a solid line. So at 2, we will have a vertical line that is solid. The only question should be which side of our vertical line are we going to shade? So let's again test it by plugging in a value. We can just plug in 0. So notice if we're plugging in the point 0, 0, well, that means we're plugging in a 0 for x. There's no y to plug in. So that would give us, 0 is greater than or equal to 2. Is 0 greater than or equal to 2? Absolutely not. So that is not a true statement. So 0, 0 does not work. So just like a couple of the ones before, we're going to shade the side of the line that 0, 0 is not on, the other side of the line, and then we're done. Now, up to this point, we've only looked at lines, but it doesn't matter if it's a line or even on the next one, we've got a parabola. How do we know it's a parabola? Because we've got an x term that is squared. Notice from previous chapters that our parabola has been shifted to the right one, and then the plus 2 tells us the parabola has also been shifted up 2. So we can go ahead and graph our parabola, and notice because there's only a factor of a equals 1 out in front, that there is only a stretch of 1. So we're going to go over to the right 1, and then we'll go up 2, and that will be the vertex of our parabola. And notice that there's a stretch of 1. So just be pulled up by a factor of 1. Notice I am drawing a solid parabola. Why? Because it was a greater than or equal to symbol. The equal to means I need to draw a solid graph. Now the question is, am I going to be shading below the parabola or inside the parabola? There's no way to know without testing a point. So I'm going to test 0, 0. Luckily, that is not on my parabola. So there's 0, 0. Let's plug in a 0 for y and a 0 for x. So if we plug in a 0 for y, that gives us 0 is greater than or equal to. Well, on the right-hand side, that gives us 0 minus 1, which is negative 1 squared plus 2. Well, the negative 1 squared is 1 plus 2 is 3. So that gives me 0 is greater than or equal to 3. Is 0 greater than or equal to 3? Absolutely not. So that means 0, 0 will not work. So we'll shade the other side of the parabola, which means we're going to shade the inside. And we're done. On the next problem, notice both x is squared and y is squared, which means we actually have a circle. Notice there is nothing with the x's and nothing with the y's, which means the center of the circle is actually 0, 0. But on the other side, we have a 25, which means my radius is actually 5, which means to draw my circle, I'm going to start at my center of 0, 0, and go out 5 in every direction. Up, down, left, and right. Now, moving forward, notice that because I have a less than, not a less than or equal to, my circle is going to be dotted. So best that you can do a dotted or dashed circle with a radius of 5 and a center of 0, 0. Okay. Now moving right along, the question is, are we going to shade the inside of the circle or the outside? Well, we need to test a point. Let's test the origin, 0, 0 again. It seems to be working for us as long as it's not on our graph, which it isn't. So we're plugging in 0 for x and 0 for y. That gives us 0 plus 0, which is 0, is less than 25. Is 0 less than 25? Absolutely. So that means 0, 0 does work. So we'll shade the inside where 0, 0 is. And we'll just shade the entire inside of our circle then. And that's our final answer for our circle graph here.